Hey guys, welcome back to my channel and I hope you are all doing extremely well. This is lecture 11 on my linked list series. So far I covered 10 lectures and from lecture number 4 we started solving actual linked list problems, and before that I spent 3 lectures on basic introduction and how to perform insertion operations and deletion operations on a linked list, and I highly recommend you to please start watching from lecture 1 till whatever I am going to post in this series. And I believe at the end of this series, you are going to be very strong in solving the linked list problems. And before going to the video, I request you to please subscribe to my channel and please do like and comment, and that will boost me to produce more videos. Without further delay, let's get into today's video. Today we are going to solve one more leet code problem. The problem number is 160, intersection of two linked lists. So in this problem, we will be given two lists and we need to return the intersect node. If we carefully observe here, list A, list B. In list A, there are total 5 nodes, 4, 1, 8, 4, 5. In list B, there are total 6 nodes, 5, 6, 1, 8, 4, 5. Here the intersect node is 8. So if our input has this intersect node, we need to return, otherwise we need to return null. Let's get into our board for a better understanding. If we carefully observe here, if my list is, let me take a different pen. Yeah. If my list is something this 1, 2, and 3, 3 is next is null. And if this is list A, and assume this is list B, and my list B is 2, 3, 7, null. In this case, there is no intersect node, right? In this case, we need to return the null. This is another input set. Let's take the valid one. 1, 2, 3. 3 is next is 4. And here it is going to be 6, 7, 8, 9. 9 next is 4. 4 next is 5. 5 next is some 6. 6 next is null. If we carefully observe this input, so there is one intersect node, that is nothing but 4. So we need to return this node 4. So these are the two different positive and negative input cases. Okay, let's try to understand how we can solve this problem. So the naive approach can be count the length of two lists. Okay, count the length of two lists and have a difference. So let's assume your list 1 length is some 7. If your list 2 length is some 4, then have a difference. 7 minus 4 is 3. So since L1 length is 7, so it has to move 3 nodes forward. So that example, let's take this 7, 1, 3, 4, 4's next is 2, 2's next is 3, 3's next is 1, 1's next is null. Assume this is my L1 and my L2 is going to be something like this, L2. So if we carefully observe here, my L1 length is 7 and my L2 length is 4. So 7 minus 4 is 3. Since L1 has more length, then we need to move 3 nodes forward. That means we need to be at this position. We need to skip this 3. So now my L1 and L2 is pointing at the same positions. I mean to say in terms of length. So it is pointing to this, it is pointing to this. Then we need to see if L1 dot next is equals to L2 dot next. In that case, just return that node. So this is the naive approach actually, because here you need to find the length of two lists and you need to what I can say move forward of the list whose length is more. Okay, the difference here, and you need to start iterating those two. Then if there is an intersect node, definitely they are going to point the same node, then you need to return that one. So what are the time and space complexities with this approach? The time and space complexity is going to be big of n plus m, where n is the length of L1, m is the length of L2. and the space complexity is going to be big of 1. So this is the first way of solving this problem. What is the second way? Okay, let's try to debug this solution first. If I have a list something like this, 1, 2, 3, 3's next is 4, 4's next is 5, 5's next is 6, 6 next is null. And I have something like this, 7, 8, 9, 9 next is this one. So assume this is L1 list, this is L2 list. So what I'm going to do here is I'm going to have a two pointers. One is going to point the head of the list one, and whereas other one is going to point to the head of the list two. Okay. So let's assume the references are A and B. What I'm going to do here is if A not equal to B, till that condition I go forward. Okay, let's see. Is 1 equal to 7? No. And here we are not targeting to check values. It's all about the nodes. Okay, node address. So we check direct node like A not equal to B. We are not checking something like A dot val not equal to B, B dot val. Okay, this is not we are doing. We are checking the node. Okay, let me erase these things. Yeah. Is A not equal to B? Yes. Then what I'm going to do here is I will go to here and I will move B to here. Are they equal? No. Then I'm going to here and I'm going to here. B. Are they equal? No. Then I'm going to here and I'm going to here. Are they equal? Yes. They both are pointing to the same node. That means you can return either A or B. This is one happy flow. Okay, so if I take two references and if the length are same, okay, and if they have an intersect node, then this approach is going to work. I mean, whatever I'm telling here, it is okay. But let's try to see the different case. Let's assume your list is something like this. List 1, I mean to say L1. 1, 2, 2's next is some 4, 4's next is some 5, 5's next is some 6, 6 next is null. And your L2 is going to be something 9, 9 next is 8, 8 next is some 6, 6 next is some 3, 3 next is 4. If you apply the same logic of previous one, like whatever we applied here, if we try to apply the same here, it is not going to work, right? Because first initially they both are be here A and B, and they both are not equal. Then I'm going to move A here and I'm going to move B here, and again they are not equal. Then I'm going to move A here and I'm going to move B here. They are not equal. Then again I'm going to move A here, then B here. Again they are not equal. Then I'm going to move A here, then I'm going to move B here, and again they're not equal. Then I'm going to move A here and I'm going to move B here, and again they're not equal, but A is pointing to null, so there is nothing for me to go further. Then I will come out of that complete iteration, and I end up having no result in my hand, right? So this is not going to work, but the same approach with a slight difference can work. Let's see how it is. I'm going to take the same input 1, 2, 2's next is 4, 4's next is 5, 5's next is 6, 6 next is null. And I'm going to take 9, 8, 7, 3, 3 next is this. So initially what I'm going to do here is, and please I request you to pay some attention from here. This is the actual solution. So initially I'm going to have two pointers A and B. What I'm going to do here is I'm going to move my A and my B forward until they both are not equal, right? And in the process, if my A is at null, okay, if my A is pointing to null, then I am going to make my A to point to the head of the list B. So assume this is list B, LB, and this is LA. Okay. And guys, please understand, if my A is pointing to the null, that means what I'm going to do here is I'm going to point my A to here. And if my B is pointing to null, so assume my L1 length is more than L2 length. Okay. So in that case, I'm going to point my B to the length of L1. Okay. For understanding L1 and L2, let's take. Okay. Let me debug it for you. Okay, great. Now let's see. Initially, A is here and B is here. Are they equal? No. And is A pointing to null? No. Is B pointing to null? No. So these three conditions every time we need to check. Then I'm moving A forward and I'm moving B forward. Are they equal? No. Is A pointing to null? Is B pointing to null? No. Then moving A forward, moving B forward. Are they equal? No. Is A pointing to null? Is B pointing to null? No. Then moving forward. Same. Are they equal? No. A is not null, B is not null. Then A is going to point here. Then B is going to point here. Are they equal? No. Is A pointing to null? No. B pointing to null? No. Then A is going to be here, B is going to be here. And please pay attention here. Are they equal? No. But A pointing to null, right? That means we need to change A pointer to head of this list. That is nothing but L2. Now let's see. Are they equal? No. Then is A null? Is B null? No. Then A is going to point here. Then B is going to point here. Are they equal? No. Is A pointing to null? Is B pointing to null? No. A is going to be here. B is going to be here. Are they equal? No. Is A pointing to null? No. Is B pointing to null? Yes. Then my B is going to be here. Okay. Now, are they equal? No. Is B pointing to null? Is A pointing to null? No. Then my A is going to be here and my B is going to be here. Are they equal? No. Is A pointing to null or B pointing to null? No. Then my B is going to be here, my A is going to be here. Are they equal? Yes, they are equal now. So just return 4. So what essentially we are doing here is, so we started traversing list 1 and list 2. So whenever any pointer pointing to the null, then we are swapping their pointers. Let's assume initially A started with L1 head and B started with L2 head. So if A pointing to null, then I'm changing its pointer to L2. And if vice versa, I mean if B points to null, then we're going to change. Why we are doing this? So interchanging of this pointer will help us to point the exact intersect node, because they are now going to have different what I can say sizes, right? And they already iterated once, so that will help us to point the, I mean locate this intersect node. Okay, so this is how this approach is. So I hope you understood the approach. With if not, please do let me know in the comment section. I will be very happy to explain you in written format also. What are the time and space complexities with this approach? Time complexity is going to be big O of n, space complexity is going to be big O of 1. Okay, let's try to run the code. I already have it. The base check is if head equal to null, or else head A null, head B null, just return null. And otherwise take first and second. First points to the head 1, second points to the head 2, head B. And if first not equal to second, okay, that is what I said, like when they both are not equal, then we need to move forward, right? If first is null, if that is pointing to null, just assign it to the head B, okay? Otherwise, just to move forward. And the same logic applies to the second also. If second equal to null, just assign it to the head A, otherwise move it forward. And at the end of this loop, you will be in a node where it is going to be your intersect node. Otherwise, you are going to return null. Okay, that is how it is. So let's run it. Yeah, let's submit. Yeah, it got submitted. Great. It took 1 milliseconds. So this is all about this problem. And one suggestion from my side is take different input sets, okay, and try to debug this logic, okay. And I hope you are going to find it very useful. And I hope you learned something new today. Please do subscribe to my channel and please do let me know how I am doing. Thanks a lot.